Okay, so this last little section, 19.3, this section deals more with localized winds, winds that aren't on such a large scale. They aren't global, global wind patterns or global weather systems. They're more local, regional. They're just a lot smaller, so they're going to be influenced by local things that are smaller features that just aren't going to play into global sized things, but they do affect local things. Hills, mountains, plains, water, bodies of water, those sorts of things will affect wind, they'll affect weather in an area or a region. I mean, even cities will play into stuff like that. So sea and land breezes. This is a good example of the effect that uneven heating can have, and the fact that land and water heat up and cool down at different rates. So if you remember, we talked before about how land heats up and cools down more quickly than water, and also to greater temperatures. So land is going to heat up faster, and it's going to get hotter than the water is going to, and it's going to cool down, and it's going to get colder than the water is going to as well. So on the left, the sea breeze, and also remember when you're talking about winds, you name those winds or you talk about those winds from the direction that they're coming from. So with the sea breeze, you have wind coming from the sea, and that's caused because the sun comes up, starts to heat up the land faster than the water. So you have hot air rising above the land. The water is still cooler, so air will cool over that. So you have air that's descending, so you get a convection current, which forms a sea breeze, which brings wind from the water, from the sea, towards the land. When the sun goes down, that whole thing flip-flops. The water now is going to be warmer, so you have hot air rising above the water. The land is cooling down more quickly, so you have cooler air above that that's descending. So now you have a land breeze, another convection current, but now it's just in the opposite direction. So it's blowing out to sea from the land. And these are localized things. It's not going to affect the whole state or something like that. It's it's a very localized thing, but it is a good example of how uneven heating of different materials can lead to the specific local weather phenomena. This next one, valley and mountain breezes, we're not going to get into too much. Obviously mountains can affect wind and weather patterns. If there's wind blowing and it comes into the mountains, I mean, it's got to go somewhere. This also depicts a bird that's circling and soaring. Birds, well, certain types of birds know where to find these updrafts. They know where to find air that's moving upwards, because that's what they use to gain altitude, so then they can soar around, look for dead animals and eat them. Aside from air being pushed upwards because of mountains or cliffs or something like that, there are also things called thermals. So that's basically just hot air that's rising. These birds are very good at finding these. They know, where they're located, and they're caused because of things on the surface that are heated up, and things that are heated up more so than the surroundings. So this is kind of a man-made version of the same type of thing, except with a glider. So it's essentially an airplane, it just doesn't have an engine. So glider pilots, just like certain types of birds, look for areas where it's going to, the ground is going to produce a lot of heat, dark surfaces, it has, dark field, areas where there's lots of blacktop. You're going to avoid areas where there's water, because that's not going to produce a lot of heat upwards, since they're trying to stay in the air as long as possible. And actually, glider pilots do look for birds that are soaring, and they will go to the areas where those birds are, because the birds are a lot better at finding this stuff than we are. Their lives depend on it, so we kind of take advantage of that. Wind direction. The prevailing wind is just a term used for the direction that the wind blows from most often. Here in the US, the prevailing wind is a westerly wind. It's from the west. And it's the wind that's most responsible for all of our weather patterns in the US. Well, most of them, I guess. I mean, there are always some oddballs, but the vast majority of our weather patterns and our weather systems and everything follow the path of the westerlies and are moved across the US by the, because of the westerlies. And it's, kind of a southwest to northeast kind of movement. It's not just straight west. But that is definitely the prevailing wind for us here in the continental US. If you ever wanted to measure the speed of wind, that's when you would use a scientific instrument called an anemometer. This picture actually shows a couple of different instruments, but the anemometer is at the top. So those little metal cups, the wind blows and it catches in that cup, and then it spins that thing around. Faster it spins it, then it registers that, translates it into a speed, basically. There are different varieties. I mean, you can get handheld ones that about the size of a phone, except they have a hole through it with a little fan blade. So you hold that up in the air, and then wind blows and spins the fan blade, and then the faster the blade spins, faster the wind, and it calculates the wind speed. But main thing is it's the name of the instrument is anemometer. And then the last little thing, El Nino and La Nina. These are weather patterns that, like it says, every 3 to 7 years. So it's not a yearly thing. And it's not necessarily a set period of time. And while it does affect our weather here, it really affects the weather further west, California and the Rockies, kind of getting into the Great Plains. Essentially what happens is whenever there's an El Nino year, water in the Pacific that's cold or cooler water becomes warmer because of shifts in the currents in the oceans. And in the La Nina year, it's the opposite. So water that's normally warmer becomes colder. And those things affect weather because, in an area where you might normally have colder water, you have warm water, or, vice versa. In an area where you would have warmer water that's affecting weather, now it's colder water. So, and here's just a illustration of that. So normal conditions, you have cooler water here in the Pacific, and warmer water across the Pacific. With El Nino, that warmer water, has warmed up that cool water off the coast of South America and the Pacific. So it does affect us, but it affects more weather out west.